The word to Nell Watson, who will speak about a quite interesting concept that that was the first time I heard about it, and I'm really very curious about this automated externality accounting. The floor is yours, Nell.
Thank you very much indeed, DJ. Our world is made up of correlations. Some of those correlations appear relatively straightforward, like one side of our face tends to mirror the other side. Most people with big hands also tend to have big feet as well. But some correlations are very complex. We might have an intuition about something, but consciously we can't quite declare why we may feel something. And yet we have that hunch that we just can't resist. Machine intelligence helps us to make sense of these kinds of tenuous correlations and connections between things, those which are present, but that we ourselves find difficult to describe or to put into words. In essence, machine intelligence today enables us to make sense out of chaos and to automate the ineffable, those things that we cannot easily put into words or describe, but sometimes we know them when we see them. We have descended through supervised learning and deep learning, and now into more esoteric forms of machine learning, such as meta-learning. This is a step forward towards a more generalizable form of machine intelligence. Meta-learning agents can compete with each other in order to save themselves or to figure out how to break into something and get access to something that they otherwise couldn't, sometimes even by exploiting the rules of engines or exploiting aspects of physics. And across several iterations, these agents can then learn to, in this case, steal the ramp first before the Reds can use it. And from this method of learning, they can perform extremely complex and extremely sophisticated ways of optimizing for the world or ensuring that an outcome happens or does not happen. Recently, we've seen the release of new technologies such as GPT-3, which are phenomenally capable at transforming text in new ways that haven't been possible before. These kinds of algorithms can turn natural language directly into code that you can then edit yourself or immediately deploy in live environments. These technologies can then translate text into pictures, so you can describe an object and see it breathed into existence. Now, these transformer-based technologies will very soon be able to solve all kinds of problems that seemed purely the domain of human intelligence until very recently. And the reason for this is that the secret is out that having colossal sized models gives a disproportionate return on investment. At the same time, whilst these gigantic models are being made, the cost of creating and deploying machine intelligence has absolutely precipitated. And so now we can democratize these technologies to more people. Machine intelligence is starting to get very personal. It's starting to get local. And today, your machine intelligence agents that you have in your kitchen or in your pocket are able to talk to each other for the first time. And now all kinds of different smart and formerly non-smart devices are being able to become smart, being able to join these networks of things. We can plug in a little sensor like this and start to understand the world in new ways, to understand whenever the pot is about to boil over or when a light has been left on. We can use these kinds of technologies to listen to machines for preventive maintenance, to understand when something might be about to go wrong before it does. But traditionally, there have been limits. IoT has relied upon batteries. It's relied upon expensive electronics, and that's changing. Now we have IoT systems which can be powered purely by ambient electromagnetic radiation. Their antennas can take in some passing radio frequency waves and use that to power themselves. Here in another example, we have a mechanical system.
Technical aspect, Nell, sorry. At the moment, we see only one not moving image since about 2 minutes. I don't know if there is a technical thing or is this...
Okay.
Yeah, no, it's okay again.
Okay,
no, it's okay.
Okay, okay. So now we have technologies which can, as a ratchet turns, two little pieces of metal touch each other. And that actuation can be detected through backscattering of wireless radiation. And this means that you can understand when a pill bottle has been opened, or how many times, or perhaps how much fluid has passed through a bottle, without needing batteries, without needing circuit boards. And so everything can be connected to the cloud in wireless ways without any expense, without any maintenance, etc. This is a real game changer in the Internet of Things. But there are some potential downsides in terms of security. There have been a lot of scandals reported recently where IoT devices get owned and turned against those who have previously enjoyed them. If we are to enjoy the benefits of machine intelligence and IoT, we need to weave good security and good cryptographic techniques into them. Today, the latest machine intelligence systems operate on a principle of tokenization. The parameters that they are working with and the data that the input and output is tokenized. And in fact, this is kind of a parallel evolution with many cryptocurrency systems as well. And so presently we're starting to see a convergence between the worlds of crypto, AI, and IoT. And they are going to be much mutually enhanced by this coming together. We're entering a world now where we can perform very complex functions in a decentralized way, a way which is very fast and which is provably, formally, logically, cryptographically secure. And it has been observed that when civilizations figure out how to do complex things in an effortless way, that they tend to advance in ways which were not previously possible. And I think that these technologies are giving us new ways to manage our planet and manage our footprint upon it. We've mastered the art of production. In fact, about 160,000 plastic bags are created on this planet every second. We have a plastic bag maximizer, essentially. We ourselves are the gray goo eating the planet and turning it into plastic bags. We need to master not only production, but also consumption, also the end of life for our production once we're done with these things. Our economy today is about some people in the planet enjoying incredible luxury, but at the cost, a shifted cost, of somebody else having to pay for that enjoyment. Somebody else may be very far away. They may be human. They may be non-human. Those costs fundamentally need to be paid by someone. We think of capital in terms of finance, yes, but we tend to think less often about capital in terms of natural or environmental capital and social capital, the well-being and enjoyment of human beings and other non-human animals. Essentially, our modern economy privatizes benefits and externalizes costs onto others. And this is accepted. It's accepted as being how things are, because until this point in history, we haven't had an effective way of managing those shifted costs, those externalities in economics terms. And finally, that may be beginning to change. Today, the Google Street View car, which comes through your neighborhoods, doesn't just have cameras on it. It's also sniffing the air. It's figuring out what kinds of chemicals and particulates are in there. And this network, this fleet of cars, was able to figure out that one industry in the US making ammonium nitrate fertilizer, that one industry was creating 3 times more methane than all other industry in the US combined. And we had no idea. We didn't know this. And methane is dozens of times more contributory towards climate change than CO2, at least in the shorter term. Finally, we do know. We can collect this information. We can aggregate it in new ways so that we can understand it and share that understanding. And once we've understood who's doing what and who's being affected, we can begin to enable redress. Technologies like Do Not Pay provide a wizard-like interface for, yes, defending against a parking ticket, but also for joining a class action lawsuit. These provide new ways of getting access to justice for everyone, which didn't exist before. And when we put all of these elements together, we come to a near future of a smart, self-aware, living Internet of Planet, one which is capable of automated detection, accountability, and redress for these externalities, a concept that I describe as automated externality accounting. I've made a little website at pacha.org, pacha.org, where you can look at some of the initiatives today all around the world who are doing work in this direction towards this concept. I believe this is going to change our future. It's going to enable us to have our cake and eat it too, to enjoy the benefits of free market capitalism, but without destroying the world and ourselves in the process. If we can master this art of understanding shifted costs in new ways, we can make so much of a difference to human well-being, to managing pollution in new ways, to enabling greater justice in society, and as well, ensuring that we can find new ways of essentially paying people to do the right thing, of aligning incentives in ways which previously weren't possible to create a world which is fairer, more just, and more sustainable for all. I invite you all to chew on this during this fantastic conference, and thank you so much for your attention.
Thank you, Nell, for this quite interesting speech. Also, by the way, thank you for you and for all participants, speakers, for respecting the time slot. And now we have time for one question coming from David. So David is asking, how will cost of externalities be included in prices paid in the market? Taxes at local or national, or I would add or international levels.
Well, externalities are often priced in through taxes, or perhaps through a Pigouvian tax by states. But that's typically rather clumsy. Only the most egregious and gross of externalities tend to get noticed and policed. And of course, there's an issue of corruption as well. But I think we can do this through tort, through civil courts, right? The evidence, the standard of evidence for a civil tort is not terribly high. And so if we can triangulate a reasonable probability, then I think a lot of these issues can be solved in a civil manner using existing court infrastructure, but amplified through machine intelligence and streamlined through initiatives like Do Not Pay.
Thank you, Nell. In a way, you answer also the comment question of James, forcing firms to take responsibility for externalities requires laws and regulations. No, but yeah, you spoke about in a way. Okay, now the last speaker before the pause is Alexander Fraxos, who will speak about the future of biomethane is in our hands. Welcome, Alexander. The floor is yours. Don't forget to unmute yourself, of course.